Welcome back to my YouTube channel. Today we'll be dealing with this activity 1.1. I've taken this activity on your textbook, right? P2 tour textbook. So without wasting of time, may you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video, only if you have not subscribed. Also, we are allowed to comment, to like, to share these videos. No problem. You can share these links any group if you feel like there's no problem there. So here we've given question 1, which is activity 1.1, says a cylinder with an inside diameter, we've given an inside diameter of 80 millimeter, has to withstand internal pressure of 17 megapascal. Fine. So for now, you're supposed to know that if you are given there, here's the internal pressure is acting there. It's acting in the same direction as the radial. So the internal pressure is the same as radial stress in the internal diameter. So it's fine. So let us check 1.1.1 says calculate the wall thickness if the maximum stress is not exceeded 3. Thickness, we have given maximum stress. Maximum, I've told you guys, when you're talking about maximum stress, is the positive maximum stress, cannot exceed. If you see this, it's a Hooke stress. It's a Hooke stress. It's simply a Hooke stress. And then Hooke stress will occur in the maximum Hooke stress it will occur if you are dealing with the internal pressure. Remember, you're dealing with internal pressure occurs in the smallest diameter, which is the internal diameter. This is a Hooke stress there. So okay, then question 1.2 says determine the Hooke stress at the outer surface. So we have these questions here, guys. We have all these questions there. This is what we have, guys. So okay, I know what I know. Okay, I can say data given, then I will correct this down. We have inside diameter, if I can say is 8, then if 80 you divide that 80 by 1000, you'll get this to be 0.08 meter. And we have radial stress there will be negative 17 megapascal so far. And Hooke stress, maximum Hooke stress is 32 megapascal. So this is the information we have, our data. See, pretty simple. This is our data. So yeah, we're dealing with internal pressure. So guys, if you're dealing with internal pressure, you can draw your internal pressure stress distribution graph. How cool is this? Here we'll have 0. Remember 0, this is our diameter D1, which is 0.08 meter. The outer diameter we don't know, we are not given. So you know how it goes. We'll experience 0. Remember, this is what we have. If you've been watching my video, this is what you'll have. They will have a 0. Then Hooke stress will never reach to 0. So here we have positive, negative. This is for Hooke stress, this is for radial stress. So we don't know the radial stress at this point. We don't know the radial. Remember that it's a minimum radial, but we know we've given the Hooke stress there, the maximum one. Yes, we are given that. We are given that, isn't it? So we're given this to be is the one 32. It's a maximum here is 34. We're given 34 megapascal. This is what is simply our maximum hook stress. We have given also the minimum, the radial stress. Remember, it's the same as the internal pressure, which will be negative 17 megapascal. We know this. There will be simply 0 megapascal. We know this. There we don't know what it is. What this is what we have. So yeah. Question 1 says when the wall thickness is given by d minus d over 2 external diameter minus internal diameter divided by 2. So the aim here is for us to calculate the internal diameter, the external diameter, then we'll be fine. So we can now, because you know these represent diameters, these vertical lines, so we can use what we are given. I can say tell the examiner at diameter, the small one, which is d, is equal to 0.8 meter. Yeah, so we know that at that, we know that the radial stress there, you can even write this diameter here if you want at the bottom of this radial like this. We know that it will be negative 17 megapascal, right? We know this, but okay, the radial, know that the radial stress is given by this formula, A minus B over D squared. Radial stress we have there is negative 17 times 10 to the power of 6. We don't know the value of A, we don't know the value of B, but the diameter is 0.08. You square that diameter. So this is simply equation 1. What else do we have? We're still under diameter, still under this internal diameter 0.2. But however, again we know, remember this line, can I show you this vertical line represent the diameter that I've highlighted with blue. So we also have in this diameter, we also have again, also have the hook stress. So okay, that's nice. Also what, sorry about that, we also have the hook stress, but the hook stress we are given, which is the maximum hook stress, we are also given the maximum hook stress at this diameter 0.8 is equal to, if given that the hook stress is equal to 34 megapascal. Remember, we're still at diameter 0.08. So what is the formula for this? We know the hook stress, can say, does not change. The formula for hook stress, it's A plus now B over D squared. Fine, we know this is 34 times 10 to the power of 6. We don't know A, B, we don't know. The diameter is 0.08. You square this guy. Then you can make A the subject. If you make A, you'll take this to the other side, this, so A will be equal to 34 times 10 to the power of 6 minus b into 0.08 squared. Right, therefore this is equation 2. Then you can say substitute equation 2 into equation 1. Then what is equation 1? Here it's our equation 1. This is our equation 1. Again, copy this equation. We have our equation 1 here. Let me paste it here. As you can see, this is our equation 1. You can substitute the given negative 17 times 10 power of 6. Where we see a, remember a is all of this. It's all of that. A is all of that. I can just grab all of this. Let me copy that. The a is this. Substitute that a here. There is a. It's all of this. So we have a. Right, it's a. But we also have this. Again, will be minus b over 0.08 squared. So this is math. Constant, I will have minus 17 times 10 to the power of 6. Then I take that to the other side, will be minus. So this will be negative 34 times 10 to the power of 6. It's a math. Here we have minus b all over 0.08 squared minus b all over 0.08 squared. This is simply math. Then now you see we have b, the LCD is the same. This is still there. If I can say 17 times 10 to the power of dividends 6 minus 34 times 10 to the power of what? Of 6. Simply have a nice value, which is minus 51 times 10 to the power of 6. This would be minus b, minus 2b. If you know the maths there, it must be minus 2b. You take 1, remember they are the same, would be 0.08 squared. This is maths. This is maths. If you know maths, you want to make b the subject, you'll multiply by the reciprocal both sides, 0.08 squared all over minus 2. What you do also this side, you'll multiply by the reciprocal. This and that will cancel. This and that will cancel. You'll have b here. There you'll have 0.08 squared multiplied by negative 51 times 10 to the power of 6 divided by minus 2. Then it's a matter of punching here. If you punch there, that calculator 0.08 squared minus 51 times 10 to the power of 6 divided by negative 2. nice value. Have 2.5 times 10 to the power of 6 is equals to p. So yeah, therefore the value of p is simply equals to, as now is a unit. What about the value of a? The value of a, we want now the value of a. This is the value of a. Remember, from this equation, that was the equation 1, isn't it? So we want the value of a. Put 25 for UCP times 10 to the power of 6 all over 0. Let me write it here accurately. There is minus here, then you have 25,5 times 10 to the power of 6 all over 0,08 squared. So yeah, what will be a method of punching here? 32 times 10 to the power of 6 minus 25.5 times 10 to the power of 6 divided by 0,08 square that in negative 3,95 yeah, 95 times 10 to the power of, oh, it's 9. Oh, this is so big. It's so very small, but because it is negative, right, I can round this to which decimal? Fourth decimal, please. Let me round it to 3. It will be like this if I round it to 3. Will depend. Maybe it will be slightly different with the method. Will depend on the decimal, but yeah, this is the one and the same thing. So we have done with the values of a. So why did we calculate this? Because now from this graph you can check at the extra, we want the outer diameter. Then at outer diameter, we know there we have radial is equal to 0 is what we know. So yeah, you know, at the external diameter, no, at the external diameter, our radial there is equals to 0 megapascal. So yeah, what is radial? It's a minus b over d squared. But we know that this is simply 0, will be 0. The value of a is that minus 3,95 times 10 to the power of 9 minus, so what is b? Sorry about that. The value of b, here it is 25, there, that is the value of b. We had b to be equals to this, right over the diameter, which is 0,08. We square this guy Then what did I do? Oh, sorry. You remember the external diameter, we don't know. This will be d squared. It's fine. Remember, this is external diameter. We're at the external diameter. We don't know the diameter. Maths, I take that will be 95 times 10 to the power of 9 equals to minus 25,5 times 10 to the power of what? 6 over d squared. So there's something there supposed to happen. There's something that we've messed up here. Messed up something here. Okay, let me check. The value of a is something. Let me check first. Okay, what is the value of a? Was this? Just took that and became negative like this, which is fine. Then substitute that the value of a, which is this, then this paper we have this, then we took that and became negative like that, and then we had this there, we have minus, minus 2b over this, yes, then we punch that side. I said 17, negative 17, because this side it was negative, isn't it? Negative 17 times 10 to the power of 6 minus 34 times 10 to the power of 6. Yeah, I got this. Okay, which is fine. The water is what I had. Then we will have this. Then multiply. I think here I did not multiply, I subtracted. Remember, this is supposed to be multiplication. Yeah, I think maybe the problem is there. We have, let me check, 0.08 squared multiplied by negative 51 times 10 to the power of 6. Then I'm supposed to divide this by negative 2, right? So negative 2. Yeah, guys, here is the value of b. You see, I did the mistake. I can feel that this is the mistake. B, then b will be equals to 16. I just made the mistake. 163, 2 times 10 to the power of 3 is b, because here I did not multiply it, I subtracted. You're supposed to multiply by negative 51 times 10 to the power of 6, then I divide by this. So yeah, that was the problem. I can feel why I'm end up having a negative there down. Okay, which is this is cool. Then we had this b, then a, we are still using the same formula, does not change. If we want a, the a will be equal to 34 times 10 to the power of 6 minus b, it's 163, 2 times 10 to the power of 3 divided by first, let's check the a. Okay, I've substituted. Okay, now it's how I found a. I have to get a now by substituting this b back, Right, let me get the value of a. Let me get the value of a. I'm dividing like this. Okay, so what about this, guys? Just a little mistake there. So yeah, as I'm punching this, supposed to get that a 34 times 10 to the power of 6, right, minus 63,2 times 10 to the power of 3, divided by 0,08, 0,08, 0,08. Then you square this, then this will simply equals to that. Yeah, yes, now it's pretty good. Then a is simply equals to 8.5 times 10 to the power of 6. Yeah, then at the external diameter, this is still right. We know, okay, the pressure, I've explained this, the radial is 0, whereby that is the formula. Now here will be wrong, our values there, so we'll have 0 is equals to the a. What is the value of a now? It's 8.5 times 10 to the power of 6 minus the value of b there, whereby b is that 110. Let me just correct this b. So this is the value of b divided by our diameter. Our diameter we don't know at the external, isn't it? So we take this to the other side, it will be minus 8.5 times 10 to the power of 6 is equal to negative 163,2 times 10 to the power of 3 divided by d squared, right? Then I multiply there by d, minus 8.5 times 10 to the power of 6 d squared to negative 163 times 10 to the power of 3. Right, now we're in the good track. Then I divide by negative like that by that value coefficient. Then yeah, with d squared, then the negative and negative will cancel. Take the square root both sides of this. If I take the square root of 163 times 10, 8.5. So yeah, then this and that, we have d, then the meter is here now. Okay, 163 times 10 to the power of 3, 8.5 times 10 to the power of 6. Then look at 0,138. This is meter. Then if we want it to be in millimeter, multiply by 1000 will be 138 millimeter. Right, so this is this is our external diameter, but we wanted thickness. The thickness is d minus d divided by 2. So since all these are in millimeter, I can say 38 minus 80, because also 8 is in millimeter, divided by 2. That means our thickness, the value of the thickness must be in millimeter. With 138 minus 80 divided by 2, whereby this is simply nicely 29 millimeter. So yeah, this is the thickness. Yeah, that is it, guys. Sorry that I've made mistake first there. Okay, now here 1.1.2 they say determine the hoop stress at outer surface. Our hoop stress at outer surface. Outer surface, if you have a density, that means is this. It fancy ways outer surface. They want external diameter. Hoop stress at external diameter. So that is easy, isn't it? So now hook stress the outer diameter, the diameter that we got, hook stress is B over that. Then this hook stress, the value of A, it was 8.5 times 10 to the power of what, to the power of 6 plus the value of B, it was 163.2 times 10. I still have it here. What is the value of that? Wait, on the value of B, value of B is 163.2 163.2 times 10 to the power of 3, like that. The diameter we got to be was 138. Then in meter will be 138 squared. Remember, we've just got it here, isn't it? So yeah, this will be the hook stress. Then 8.5 times 10 to the power of 6 plus 163.2 times 10 to the power of 3 divided by 0.138. You square this guy, then seventeen, 0 is like this. So we'll affect this, then will be simply 7 megapascal. So this is what, 17.07 megapascal. This is what we have there. So this is the value here. That value that we got, we have them must it is here. If you see your graph there, you see is the mean. You see it is small, is this one there. You see here, you have all these values. Here you have 0, you have negative 17, you have here 34, all this. So yeah, this is what it is, guys. So yeah, so for these guys, for this, in this question 3, 2 and 4 was just an advertisement. I will do them separate. So I'm done with these 8 marks. These I will do them. I will do this question separate. As you can see, question 2 says a thick wall has internal pressure. We've given there is made of material as maximum tensile. Yeah, as you can see. So guys, do not worry, this one, if you just stay tuned, I will do it separately. You just have to subscribe there to my YouTube channel. Then this, I'll be dealing with these two next.